Ask any physicist about black holes, and they'll tell you that they exist.
But I could say, there's a unicorn in these woods, and you would rightly say, no, there isn't, because I can't see it. But I could reply, yes, there is. It's there, but it's invisible. And you would probably think that I'm daft at best. But what's the difference between my imaginary unicorn and a black hole? See, black holes, by definition, are invisible. You can't see them. So how do we know that they exist?
The first clue that black holes are real came from here, in the Cambridgeshire countryside, in the 1950s. While the rest of the country were listening in to wireless radio at home, out here, they were listening in to a different radio signal. Radio signals from outer space.
This is the Mulholland Radio Observatory. Back in the 1950s, some of the first radio telescopes in the world were built here. And when they turned them to the skies, they heard this.
That loud hiss is the telescope passing over a strong radio signal in the sky. But they couldn't work out what it was or where it was coming from.
Now imagine this torch is that radio source sending out a beam of radio waves. So radio telescopes in the 50s could detect radio sources in the sky, and they could tell roughly where those beams were coming from, somewhere over there, but they couldn't tell precisely. But then an astronomer called Cyril Hazard had a very clever idea indeed. You see, he knew that on the 25th of August, 1962, the moon was going to be in the same patch of sky as the radio source. So he just watched and he waited, and he saw that as the moon travelled across the sky, it went in between the Earth and the radio source and cut the source off. And then, as the moon continued its journey across the sky, the radio source reappeared. So by measuring precisely when the beam disappeared and appeared, Hazard was able to pinpoint precisely the source of the beam.
It was tracked to what looked like a faint star in the constellation Virgo, just one tiny dot of light among the millions of others in the sky.
This is an image of that piece of sky, and that point of light just there is the source of the radio signal. Now, pretty much every point of light you can see in this image is a star inside our galaxy, inside the Milky Way. But this point of light, the origin of that radio signal, is 3 billion light years away, and yet it can still be seen. No star could shine that brightly. So what could that possibly be?
The astronomers called it a quasi-stellar object, or quasar for short, because they didn't think it could be an ordinary star. But black hole theorists knew of one way that stars could appear that bright, and that's if they were falling into a black hole. Stars falling into a black hole would be completely ripped apart. Gas and dust would be torn from their surfaces as they spiraled inwards at tremendous speeds, and emit so much radiation that it could be seen right across the universe. And that means we could detect it here on Earth.
So what the astronomers here in Cambridge realised was that that quasar they were seeing was actually a black hole, a giant black hole, and the light and radio waves was coming from whole stars having gas and dust ripped off them and spiralling to its destruction inside the black hole.
Over 100,000 quasars have now been discovered. All are thought to be supermassive black holes actively feeding on stars. And all of them are found in exactly the same place, right in the centre of galaxies. So does that mean that there's a black hole at the centre of every galaxy?
our galaxy, the Milky Way, couldn't have a quasar like the one discovered here in Cambridge at the centre, because we'd see it. It would shine as brightly as the full moon. It would be visible in the daytime. But imagine a black hole that's eaten all the nearby star systems. So there's no gas and dust to spiral in, and therefore there's no radiation to make it bright. So it could still be that there is a supermassive black hole at the heart of the Milky Way.
One group of scientists spent 16 years painstakingly searching for it. And this is what they found.
This is, I think, one of the most remarkable graphics in recent scientific history. It's a picture of the centre of our galaxy and the stars that orbit around it. They're known as the S-stars. Now, the inner two stars you can see there are orbiting very fast around some central object. Actually, they reach speeds of around 11 million miles an hour. And when you plot the orbits out that precisely, you can calculate the mass of the object they're orbiting around. It turns out the mass of that object is 4 million times the mass of the Sun. But there's more than that, because you can also work out the maximum size it can be, because the inner S-star gets as close to that central object as Neptune gets to the Sun. So here we have an object 4 million times the mass of our Sun, compressed into a space smaller than our solar system, and it's invisible. The only thing that could be is a black hole at the centre of our galaxy.
Black holes started out in physicists' imaginations, but we now have evidence to prove that they're real. And not only do black holes exist, but we now suspect that they form the heart of nearly every galaxy in the universe, including our own.